Well, thank you for joining me on this question. We're going to be looking at permutations. Whilst there's a section which says combinations down below, this is pretty much based on different ways that you can represent characters or objects where order, in fact, does make a difference. So a permutation means the different order is a different permutation. So we've got this word and it says maths. 1, 2, 3, 4, 5. 5 letters to choose from, 5 objects, 5 letters. And question 10 says up above, the number of the 5 letter arrangements there are of the letters of the word maths. And we're talking that above the line says express each of the following, both numerically and using factorial notation. So let's go back to, I don't know how I can go back here. Here we go. So we've got 5 letters, 5 positions. So for the first position, we've got 5 choices. It could be any one of the letters. We use that letter up, and we've got 4 left for the second position, 3 for the third, 2 for the for the fourth, and 1 choice remaining for the last one. So the numerical number of ways we can represent 5 letters is 20 times 6, 120. That's numerical, and the factorial is simply starting at 5, multiplying all the way down to 1. So that's the factorial way to represent the number 120. So that's the alternative, 120 or 5 factorial. So that's question 10. Let's look at question 11. Question 11 is the number of 2 different letter arrangements there are when the 2 letters, what does that say? I can't read it too well. The 2 letters can themselves be chosen from the letters of the word maths. Now we only have 2 positions, so I'm just going to put 2 positions, 2 letters. Now any one of the 5 letters can be used for the first position, and any one of the remaining 4 letters can be used for the second position, but we've run out. We can only use 2 letters. So there are 20 different 2-letter words using MATS, and that's the numerical. And here we've got, if you want the factorial, if you had 5 factorial, that would be all the way down to 1. But we only want the first 2, so the remaining 3 are cancelling out. So we've got 5 factorial over 3. Sorry, that should be a 3. Yeah, well, I can't see it now. Okay, there it is. Over 3 factorial. By the way, that is the same as 5 permutation 2. 5p2 is also 20, and 5p2, that means from 5, get how many permutations where we get 2 at a time, and it's 5 factorial over 5 minus that 2 under there, which is 5 factorial over 3 factorial. I'll just show you what 5 factorial looks like. And 3 factorial is starting at 3, finishing at 1. And you can see that we would cancel that, and we would be just left with 5 times 4 is 20. So that's 5 factorial over 3 factorial. Just a little extra thrown in. Okay, so I hope this has helped. We've just looked at a few questions from above, question 5, question 10, 11. I hope this has helped. Until next time, stay happy.